So of course, today is last week of classes, right? Next week, we're taking the final exam. So this week, you guys are working on finishing up chapter 11 and chapter 4. There are 3 sections total, 1 section from chapter 11, 2 sections from chapter 4. So my recommendation to you guys is to go ahead and get those 2 chapters done first. And then remember, I have opened up all the older chapters. So everything from chapter 1 to chapter 10, homework and quizzes are open. So if anybody wants to work on older homework and quizzes, to try and get your grade up, to increase your overall grade, you can do that. If you have any attempts left on the quizzes, you get 3 attempts. If you have any left, you should be able to work on the quizzes as well. And then I am giving you guys 1 chance to retake a chapter exam. So this can be a chapter exam you missed. This can be a chapter exam you maybe got a lower grade on and you want to try and see if you can get a higher grade on it. Obviously, all of these are optional. If you are happy with where you are and you just want to concentrate on finishing chapters 11 and 4 and get ready for the final exam, obviously you can do that too. So just remember, if you are going to be retaking a chapter exam, you need to request your password for this week's exam for chapters 11 and 4, and you need to request a password for whichever exam you want to retake. So let me know which exam you want to retake and I'll set it up for you and I'll send you the password. Those are the 2 things. And then next week on Tuesday, we will be taking the in-class version of the final exam. So that's what you will be doing with me on Zoom. It's an hour long. I will give you some extra time if you needed to take a little bit more time to finish the exam. That wouldn't be a problem. And then you will also be requesting a password for the take-home version of the final exam. So please keep that in mind. Additionally, I wanted to let you guys know that I am not going to be available at all on Friday and most of Saturday. I am supposed to have a procedure done, so I'm probably going to be, obviously part of the day I'll be at the hospital, but part of the day I'll be in recovery. So I will not be able to check my emails, send any replies back. So try and get whatever you need from me by Thursday at the latest. If you wait till the weekend, guys, and I'm not able to reply back, you will be stuck with no passwords and you will exam. So don't put yourself in that position. Do it right now. Go ahead, request whatever passwords you need to request. Because like I said, I will not be here Friday, most of Saturday. Who knows what Sunday looks like. So don't wait till that last minute. Do it now. And if you don't and I can't get to you, then like I said, I'm sorry, but you will end up, not being able to take that exam. So don't wait till the last minute. So for today, what I wanted to do was, chapter 11 kind of continues with that idea that we were talking about, with the hypotheses testing in chapter 10. So chapter 11 continues with that idea. And then chapter 4, we actually get into, correlation, scatter diagrams, and that sort of thing. So I do have some examples that I wanted us to work on. So let's go ahead and pick one example from chapter 11, section 1, and then we'll move on to chapter 4. And Ali, I saw your message. I hope you feel better. Thank you for letting me know. Okay, let me make sure. I wanted to make sure I didn't forget to mark you guys down for attendance. Okay, so for The example from chapter 11, I actually have number 11 that I thought we could work on. Okay, right over here. So this one is talking about in 1948, an organization surveyed 1,100 adults and asked, are you a total abstainer from, or do you on occasion consume alcoholic beverages? So out of these 1,100 adults surveyed, 385 indicated that they were total abstainers. So this was from 1948. Now they are saying in a recent survey, the same population was asked of 1,100 adults and 341 indicated that they were total abstainers. So again, you can see we have, different statistics from both 1948 and from a recent survey. So now they are saying determine the sample proportion for each sample. So the adults from the 1948 survey and the recent survey. So again, I have created a spreadsheet for this. Oh, I didn't mean to do that. So we'll make a copy of this. Now, if you wanted a link to this file, which I guess technically I could work in this. All right, on your Zoom chat, you should see the link coming through for this chapter 11 spreadsheet here. And you know what, let's just work in the chapter 11 itself so you guys have something to look at. So they're both 1,100 as our total population. And some of these will be very similar to what we did last week. So you will definitely see a lot of similarities, in the testing and stuff like that. So over here, we have, and let me get this guy out separate. So we have the survey from 1948. We had 1,100 adults surveyed, and out of that, 385 said they were total abstainers. So that's going to be your X1 value, the 385. And then in the recent survey of 1,100 adults, 341 said they were total abstainers. So that will be our X2 value, so 341. Now, the first part they are asking us to calculate here is our sample proportion. So again, for your sample proportion, we are talking about taking, 385 divided by 1,100 and 341 divided by 1,100. So very similar to, we were calling it, I think, point estimate in the last example. So basically, again, just, click on the cells, 385 divided by 1,100. And then for the P sub 2 will be 341 divided by the 1,100. So you can see what those probabilities are coming out to be. The proportions, you have 0.35 and 0.31, and they want us to go to 3 decimal places. So this will be 0.350. And you do have to put the older 1948 value first and then the recent survey. So that will be 0.310. Okay. And then we'll check that. So again, very simple. And since this is not based on raw data, this is based on, a survey, obviously you just have to use the numbers that are available to you. The next thing, remember, we always check to see if we are able to use hypotheses testing or not. So this is where, we check for this calculation here. Make sure this is going to be a number greater than or at least equal to 10. So we'll do this for both 1948 and the recent survey. The other thing we have to make sure that our population is, or at least the sample that we are looking at, is less than or equal to 5% of the population. So that's what this is. N1 means our sample size one, which is the 1100 people, is less than 5% of the total population. And that's an assumption we always make. We always say, yes, we can safely assume or reasonably assume that our sample size is going to be less than or equal to 5% of our entire population. So all you are going to be checking is for this calculation here. So my N1 value is going to be 1100. We multiply that with p hat 1. We just calculated that, the 0.3500. Multiply that with 1 minus P1. And you can see that's a fairly larger number than 10. So we are good to go on that. Same calculation for N2. So N2 again is also 1100. Multiply that by P hat 2, so 0.3100, and multiply that with 1 minus P hat 2 again. And you will see this number also comes out to be fairly larger than 10. The other thing that we check for here is, of course, is your sample independent or not. So, the survey they conducted in 1948, there's no reason to believe that the recent survey was dependent on the older one. They can be completely distinct groups of people. There has to be no dependency between the samples. So again, we will safely assume that our samples are independent. We will say the sample size, like I said, again, reasonably we can assume that the sample size is going to be less than 5% of the population size. And then we just did this calculation. So we know both of these numbers were larger than 10 because you had 250.25 and 235.29. So those are the three things you have to verify to see that, hey, are we able to do hypothesis testing or not? So once you get past that, we are ready to set up our null and alternative hypotheses. So they're telling us in 1948, we had 385 out of 1100 who can abstain from alcohol. In the recent survey, 341 out of 1100 who can abstain. So we just basically want to know are the two proportions equal to each other? Or in the alternative hypotheses, are the two proportions not equal to each other? So that's going to be our hypothesis testing over here. And now they're asking you to find the test statistic. And that's the calculation I have here on the right-hand side. So you can see we need to use our p hat 1 and p hat 2 values. We've already calculated that. Then on the bottom, they actually have just a p hat calculation, and that's this calculation right over here. So as you can see, to calculate that p hat, you need to add up your x1 plus x2 divided by n1 plus s2, so n2. So since you have additions on the top and additions on the bottom, we're going to put that in parentheses. So on the top, inside the parentheses, we are going to do x1 plus x2. And then on the denominator, we are going to do n1 plus n2. And you can see that's what your p hat value will come out to be. And then for our test statistic, again, we're going to make use of parentheses on the top, parentheses on the bottom, because again, you are subtracting p hat 1 minus p hat 2 on the numerator. And then on the denominator, we have two different square roots that are being multiplied together. So you will do square root, which will have its own set of parentheses. So in that square root, we are going to do just the p hat, which is the calculation we just did, the 0.33. So it's p hat multiplied by 1 minus p hat. So, just be very careful because you do have a lot of parentheses happening over here. We have the one big parentheses for the entire denominator, then another set of parentheses just for the square root, and then one more set of parentheses for the 1 minus p hat calculation. So I will get out of the first two parentheses, but not out of the last one because that takes me out of the whole denominator. So I'm going to come back into 1. I'm going to hit multiplication again. So all we've done is taken care of the first square root. Then we have that second square root again. And for this second square root, you now are doing 1 divided by n1 plus 1 divided by n2. So 1 divided by n1, we're going to add that with 1 divided by n2. And that will be the square root. Oops, sorry, didn't mean to do that. So that takes care of our square root, and that actually takes care of our denominator also. And you can see this number is coming out to be 1.99501. So this is one way of doing it. And, this is using the formula given to you in the textbook, given to you in your notes based off of that. The other way to do it, which is what I would recommend you to do, is using StatCrunch. And here's the sort of directions of how you would go to StatCrunch. So go back to your problem over here. And where it says get more help, you will see you have the option of StatCrunch available. So these last couple chapters, StatCrunch will show up in your help features. So click on StatCrunch, which will open up into a new window. Now, once you get over here, you can follow this path. So we've opened up StatCrunch. Now you want to go under the Stat menu. So right here, you can see we have the Stat menu. And let's see if I can move this a little bit to the side. Not sure we'll be able to see the whole thing. Okay, go under the Stat menu. And then you're going to proportion stats, 2 samples, and you do have 2 samples, one from 1948, one from the recent survey. And then you don't have raw data. They're just telling you that you had 1,100 adults surveyed, 385 said this, 341 said this. So stat, proportion stats. So there's our proportion stats. We have 2 samples, and you're doing this with summary. So that's the path you are taking. And this will open up this little calculator, window. So number of successes, number of observations is basically going to be, from the first sample, we had 385 who said they can abstain out of the 1,100 people. In the second survey, we had 341 who said they could abstain out of the 1,100. So the 341 will go here, 1,100 will go here. Now your hypothesis testing and the way StatCrunch does is a little bit differently. So, here we end up doing P1 is equal to P2, P1 is not equal to P2. But what StatCrunch does is it actually moves this over to the other side. So they end up actually writing this as P1 minus P2 is equal to 0. Same thing over here, they move this to the other side. And they end up doing P1 minus P2 is not equal to 0. So it's just a different format of writing our hypotheses testing here. So you will see in StatCrunch, you have P1 minus P2 equals 0 and P1 minus P2 not equal to 0. So it's the same hypotheses testing, just a different way of writing it down. And we are doing a hypotheses testing, not a confidence interval. So you do want to make sure you click on that. And let's see, I think that should be it. And we should be able to hit compute. So once you do your little StatCrunch calculator over here, you should notice, and I'll try and see if I can bring this on the same page. You should notice that our test statistic value will be the same based on what you do for the StatCrunch. You can see we did end up with 1.995087, that's a rounded answer, but you can definitely see what that comes out. Additionally, you do need this p-value calculation also from here. So, that's another information you will be getting. And for this one, for the p-value, I definitely recommend using StatCrunch to do the calculation. Because, if you look in the textbook, it's kind of a lengthy way to do it without StatCrunch. So, in our little, Google Sheet over here, we can do the test statistics, the ZStat, Z sub 0 calculation over here, but you will see I did not put how to do the p-value in here because like I said, that can be tedious. So that's why I recommend using StatCrunch to help you out in this case. So let's go ahead, put these values in. Go ahead and clear this out. So our test statistic, they're asking us to round it to 2 decimal place. So 2 decimal places, since you have 1.995, what do you think this will round up to? Since you have the 1.99 and then a 5 after that. Because if you're not careful with rounding, you will end up, obviously messing that number up. So does anybody know when you round this up to 2 decimal places, what will it round up to? You can unmute yourself and tell me, or you can put your answer in chat. Let me see what your answer comes out to be. Okay, Blue, alrighty. Rachel, very nice. Yeah, so since you're rounding it to 2 decimal places, you have 11995. So we know the 5 will make the 9 go up to a 10, which means you will have one more, value go up, which will become a 10. Carry that forward and you end up with 2.00. So be careful when you're rounding this up. Okay, come on, there we go. Test statistic. Alrighty, and then you will see this is where they're asking you to determine the p-value. And again, we will get that from our StatCrunch. And this is rounding to 3 decimal places, and that's exactly what you have. So 0.046. So now we have to, make sense, interpret what that p-value is. So basically they are saying if the population proportions are equal or not equal, one would expect a sample difference proportion greater than absolute value, greater than, smaller than absolute value of, smaller than the one observed in about blank out of 100 repetitions of this experiment. So basically, we would say that if the population proportions are equal, one would expect a sample difference proportion to be greater than the absolute value of, and then for this number that they're talking about here, we actually look at our p-value here. So you have 0.046, which is, of course, when you convert this into a fraction, since you are going out to 3 decimal places, this is actually out of 1,000. They are asking us if we were to do this out of 100 repetitions, what would our numerator end up looking like? And they're saying round it to the nearest integer as needed. So if we were to write this to 2 decimal places, this guy, the 6 would make this guy go up, which would be 0.05. So this would be 5 out of 100 repetitions is what you would be writing over here. So a little bit of, modifying of your answer when you're working on this. So basically what we are saying is if your population proportions were equal, then you would expect that your sample difference proportion that we just, did over here with the sample proportions up here on the top, we would expect that the sample difference proportion would be greater than the absolute value if you were doing, whatever your results you were observing when you did 5 out of 100 repetitions for this experiment. So that means, you would have to keep repeating this survey with different groups of people, and you would be comparing the results based on that. And then you would try and see, is your, based on our hypothesis testing, are the two sample proportions coming out to be equal to each other? Are they coming out to be, unequal, not the same to each other? So now based on this, they want to know if we need to accept or reject or not reject our null hypothesis. So you can see your two options are reject or do not reject. And then it is based on, do we have a sufficient evidence or do we not have sufficient evidence? And this is based on our level of significance. And our level of significance is given to us as 0.10. You can see that's the same in all four options. So the way to check for this is you have to see if your p-value, which is this one right over here, if your p-value is less than your level of significance. If your p-value is less than your level of significance, we end up rejecting the null hypothesis. And of course, if it's not, then you do not reject the null hypothesis. So what do you think when you look at 0.046 and compare that with our level of significance of 0.10? Is it less than? Can we reject the null hypothesis or can we not reject the null hypothesis? So again, let me see what your answers come out to be here, guys. Okay, Rachel, you are saying reject. Let's take a look here. So when you look at 0.046 and 0.10, well, just start out with that first number after the decimal. You have a 0 here and you have a 1 here. So obviously you can see that our p-value is smaller than our level of significance. And so you will definitely end up rejecting. So now the question is, are you using option A or option D? Is there sufficient evidence or there is not sufficient evidence? So are we going with option A or option D here, guys? And for this one, I usually kind of go back to my original two proportions and I try to see, is there a good difference between my two, sample proportions or not? And I kind of use that also to help me guide this. So what do you think, looking at the two sample proportions, it's 0.35 and 0.31, do we have sufficient evidence or do we not have sufficient evidence? So is there sufficient evidence that the proportion of adults who totally abstain from alcohol has changed? Has our proportion changed from 1948 to the recent survey? Option A or option D? Let me see your answers, guys. Rachel, you went with option A. Okay. What about the rest of you? Ian, option A. Yeah, because you have approximately 35% from 1948. In the recent survey, that number has gone down to 31%, right? So we are definitely seeing a difference of 4%. So I would say that is a decent difference between, okay, Kruger, thank you. So yeah, we are seeing a definite change, in that percentage going down. So we would say, yes, there is sufficient evidence. You want to go with option A. So remember, guys, this is the kind of things, you have to kind of think about, what my numbers are telling me, what my calculations are telling me, and based on that, what kind of conclusion can I draw? And that's the main goal behind these hypotheses testing and, confidence intervals and the different types of questions you are doing. Alrighty, so this was just to show you guys, what chapter 11, section 11.1 looks like. So, again, make sure you kind of work through this. So I'm actually going to close this one down. We may leave our StatCrunch open. Another thing, anytime you close a calculator, it actually, till you are working and keep the session active, you will find that here under your StatCrunch results. So you will be able to go back and find that over here. Now, once you close this window down, of course, you lose that calculation. All right, so this was our 11. Let's get into chapter 4. And let me share the link for this one over here. So you should see the link for the chapter 4 worksheet coming through in your Zoom chat. We will need to delete. Okay. Let's open up. Open one. And we are going to be working on number 14 over here. It was actually a fairly involved problem, so I thought this would be a good example to work on. Okay, so 4127 is a problem number 14, and you can see it's got 7 parts to it. So this one here, chapter 4, remember we get into correlation, talking about scatter plots. So there's different ways of doing these calculations, and I'll show you a couple of them. So again, you can kind of pick, what you are comfortable with. If you have Excel, you can also use Excel for this. So many different tools that you are able to use. So this one over here is talking about a pediatrician wants to determine the relation that may exist between a child's height and head circumference. So you can kind of see where that correlation idea is coming into. So establishing, is there a relation between the height and the head circumference for a child? So she randomly selects 8 children from her practice, measures their height and head circumference, and she obtains the data shown in the table. And then, completing the parts. So the first question is, if the pediatrician wants to use height to predict the head circumference, we need to determine which is the explanatory variable and which is the response variable. So since she is using the height to predict the head circumference, that would actually make the height as the explanatory variable, and then, the head circumference, because we're basing head circumference on the height, that becomes your response variable. So basically, height is the explanatory one and response is the head circumference. And again, you can see definitions for these terminologies in chapter 4. Obviously, again, I highly recommend you guys to look through the textbook for chapters 11 and 4, so you can definitely understand the definitions for this. So, I kind of think of this as which one is the independent variable and which one is the dependent variable. Independent is the height because that's what we're measuring. And then based on that, we're trying to predict what the head circumference will be. So that means your head circumference is the dependent variable. So, kind of using algebra terminology over here. The next thing they want us to do is draw a scatter diagram. So for this one, like I said, you can go to Excel, you can go to StatCrunch, Google Sheets, whatever you want to do. So let me show you with Excel over here. So I just went to this little, square box over here. I said open in Excel, and you will see it downloaded a file for me. So I'm going to go ahead and open that. And you will see it automatically brings in our height and head circumference data values from the homework problem. So all you need to do over here is select your entire data. So I'm actually literally going to select the entire table with the headings. And then I'm just going to go into insert. You can see that insert option on the top. And then under my charts, I want to go to scatter. And I think this is what scatter diagram is over here. And you can see that's a scatter diagram. So it literally looks like, dots kind of spread out over your entire data area. And just click on scatter diagram and you will see it gives you how this data will be spread out. And, this will give you at least a general shape of what the idea, what the example looks like. And if you wanted to do this in StatCrunch, so StatCrunch, again, you can see they copy our data over here. So again, we're going to select that entire table. And in this case, you will go to the graph option here. And under the graph option, of course, you are looking for scatter plot. And here you will have to select them. So we want our height. Remember that was the explanatory variable. So that becomes your X variable, which means head circumference will become the Y variable. And then what I do is under right. So over here under the graphing properties, I will actually click on these lines so we can kind of see that grid. So it'll be easier for us to see where all the plots, the dots will end up at. And then just select those 2 check marks and then click on compute and you will see this is what your scatter plot ends up looking like, which should look very, very similar to what you had over here. But, it just kind of looks a little bit slightly different. If you wanted to do this in Google Sheets, then you will have to copy your data over. So for that, if you wanted to copy this over, we say copy to clipboard, and then remember you have to use your Control-C on your keyboard to select and copy this over. And I'm going to paste it over here because I've already pre-created my table. And I'm just going to paste it over here. And I'll talk to you about the other calculations that just happened. But right now I just, copy this over. And then when you're trying to do your pasting, do just your Control-V. Now, in this case, if you wanted to do your little graphing over here, and you know what, let me just do this on a blank page so it doesn't look so. So just like we did with Excel, select your entire data, including the headings. And just like Excel, you go under Insert, you will go under Chart. And once you get under Chart, this one takes a little bit of designing because you can see the default is just kind of putting them all in the straight, narrow area. So you actually have to go under Customize and kind of clean this up a little bit. So you would have to then, go in, and it's actually going to be under here, the horizontal and vertical axis, where you will need to customize it a little bit. So what happens in this case is then you will have to select your maximum and minimum values. And I usually let the table guide me through that. So for our horizontal, where you have the height, look at what your smallest value is going to be. And here it looks like our smallest value is 25.25. So you can do a minimum value of 25. If for the maximum, it looks like we have 27.5. So you can do 27.75 as the maximum value. So it will spread out our data a little bit. Same thing with the vertical axis. So for the vertical axis, that is where we have the head circumference. For our minimum value, it looks like we have 16.9. So maybe start at 16.8. And then for the maximum, it looks like we have 17.5, so maybe 17.6 for the maximum. So you do have to clean up a little bit in Google Sheets, but I just want you to see how each of the three programs, Google Sheets, Excel, and StatCrunch, will get you to that same result. You know, whichever one you have access to and you're most comfortable with working, you can see that. So look at the general trend for these scatter diagrams. You will see how they start out, you know, they kind of have these two lines, you know, horizontally, you know, in the same line, then it kind of goes up, and then you kind of end up with this horizontal line and this. So that's the basic shape you are looking for when you are selecting your graph over here in, you know, my stat lab. You can make these larger by clicking on this. So this one kind of seems like, yeah, okay, we do seem to have that little, you know, horizontal shape. You tend to go up, you come back down a little lower, and, you know, go in this direction. So this guy is definitely looking good. This one is also looking very similar to that same shape over here. This one is not, because you can see the first 2 points here are actually in line vertically. So this one definitely does not satisfy our graph that we expect to see. And then the last one, same thing, these are more in line vertically. So it's definitely not C and D. So now you are choosing between graph A and you are choosing between graph B. And this is where you want to make sure, what does your horizontal axis look like? What does your vertical axis look like? Which one makes more sense? So just by looking at the two options with graphs A and B, can you tell me which one makes more sense to be our graph? This is graph A. This is graph B. Okay. Rachel, do you want to share why you went with graph A? What made you choose graph A?
Because the x-axis is mislabeled.
Very nice. Yeah. Very good, Rachel. I'm glad you noticed that. So you will see in graph A, guys, we do have height on the x-axis and circumference on the y-axis. But when you look at graph B, they actually have put circumference on the x-axis and height on the y-axis. So remember, since our height is the explanatory variable, that does go on the x-axis. So it is going to be graph A. So, you know, minute little detail, but obviously you want to be very, very careful when you are working with this. Okay, so now we've talked about how to do our scatter plots. Now let's get into our correlation coefficient, which is what that little R value is. So to calculate our correlation coefficient, you know, and again, this is basically talking about, the idea is this number can go anywhere between -1 to +1. If you are closer to +1, that actually means you have a positive straight line. Sorry about that, guys. So let's go back to our graph for a quick second over here. And so the idea here is, if I draw a straight line through our scatter plot, how close are each of these points going to be to our straight line? And you know, there's a formula for drawing this line and everything. I'm just kind of just giving you a brief intro over here. So the idea is, the closer all these dots are going to be to this straight line over here, you know, your correlation coefficient will be somewhat closer to 1. Now, if you draw a straight line and, you know, all those points are kind of scattered all over, they're not really close to the line, your correlation coefficient can be -1, or, you know, of course, anything in between. So the idea is, the closer your correlation coefficient is going to be closer to 1, that means you know, you have a pretty linear graph, and all these scatter plots are very close to this line. If you are closer to -1, that's telling us there's actually no correlation between our height and circumference. They're all, you know, randomly scattered all over our graph. And there's no relationship basically between the height and the circumference, or whatever calculation you might be doing. So that's kind of what the correlation coefficient helps us determine with the number. So that's what they're asking us to calculate over here. So let's talk about how to do this in well, we can start with Excel over here. So for this guy, you actually have to use the built-in function, which is correlation. So CORREL, so it comes out to be Correl, but that's correlation. So that's where it's coming. And this is where you would then end up selecting the explanatory variable first. So always go with the explanatory first, comma, for the second one would be the dependent or the response variable, which is the circumference. And you calculate that. So you can see our correlation coefficient is coming out to be 0.88. So not quite close to 1, but still very, I guess a whole lot better than close to -1 or 0. If you were doing this in Google Sheets, and that's kind of what you will see I have over here built in, is same function, correlation coefficient Correl. And then you can see for part 1, we have selected this one, the array 1, and this one, array 2. And of course, you will see this number came out to be very close to what we saw in Excel, 0.8879. Now, just to show you this in StatCrunch over here, with StatCrunch, let's go ahead and close our scatter diagram over here. Go under, and you can see we will go under stat. This time you are actually going under summary stats. So for the previous example, we had gone under proportion stats. Now you are going under summary stats. And as you can imagine, you need to go under correlation because that's what we're calculating. Now, using the control key on your keyboard, you will actually select both of these options because, we're doing a correlation between head and height and head circumference. So you will select that. And then I think that's it because we don't need to pick any of these other options. So just click compute and you will see our correlation over here coming out to be very close to what we got with these guys. So 0.88785275, same number over here. And here I just didn't have it going out to many decimal places, but if we wanted to, you will see we will get the same answer over here also. So they are asking us to round this to 3 decimal places. 3 decimal places will end up giving us, let's see, 8878, so 888. So that's how you do your correlation coefficient. And again, guys, I use technology for this. For this one, I do not use the formula. I just use Google Sheets, StatCrunch, whichever one you like. Excel, of course, if you have Excel on your home computers. Okay, so now that you have computed your correlation coefficient, now we need to know, so is there a linear relationship existing between height and head circumference? And as I said, the closer you are to 1, the better your answer is. You can say, yes, there is some kind of association or relation between my height and head circumference. So it's definitely going to be one of the yes options over here. So either option A or option C. Now we definitely have to figure out what they're saying. So part A says, yes, the variables height and head circumference are positively associated because we did get a positive value closer to 1. Because R is positive and the absolute value of the coefficient correlation coefficient is greater than the critical value, and we definitely need to look at the critical value over here, which will come from this table. But before we get to that, the option C is saying, yes, the variables height and head circumference are positively associated because R is negative and the absolute value of correlation coefficient is greater than. So obviously our R value is not negative, which means option C is gone. So that will definitely then mean we need to do option A. And then for the critical values over here, that's actually going to depend on what our N value was. And they told us that she selected, 8 children randomly from her practice. So we have the N value of 8. And you can see your critical value based on N equals 8 comes out to be 0.707. So that's the information you're getting from this table. And that's what you're going to type in over here, 0.707. So again, we are saying, yes, the variables height and head circumference are positively associated because R is positive and the absolute value of the correlation coefficient is greater than this number. And you can see, yes, 0.888 is greater than 0.707. So that will verify our result. So this is basically telling us, yes, there is a correlation. The height of a child can determine what the head circumference is going to be. So, and when we say there's a positive correlation, of course, we are saying the taller the child is going to be, the larger the head circumference is going to be, right? Because that's a positive correlation. We have a positive slope to our line over here. Now, this next one over here is actually asking us to convert, because as you can see, the original height and head circumference is given to us in inches, and they're asking us to convert this to centimeters. And then based on centimeters, they're asking us to compute the correlation coefficient. So they're saying, take the first 4 data values and change them to centimeters. And the conversion, as you can see, is 1 inch is equal to 2.54 centimeters. And that's what I've done over here. So what I did is, you will see I've taken each of the calculations over here and multiplied that with 2.54. So as you go down, you will see each one of these numbers is being multiplied by 2.54. Same thing for the head circumference. So I've already built that in. So when you click on this, as soon as you enter the information in the main table over here, it automatically calculates the centimeter table for us. So I've already gone ahead and done those calculations. So we can go ahead and copy these over. I'm going to move this guy out so we can. Oh, come on, buddy. And this is the part that does get a little bit tedious. Because, you have to type this individually, and that does get a little sad. But, because you have that built-in formula there already, at least we don't have to do this calculation over again, and you're just copy and pasting it over from here into your table. So they'll have you do the first 4, and then they'll have you do the last 4. So they kind of break it up into 2 parts. So again, having that pre-calculated makes it easier. We just have to get this going. So let me ask you, while I'm putting this over, what do you think? Is our correlation coefficient going to change if we change our calculations from inches to centimeter? What do you expect to see as the new correlation coefficient? Will it be same or will it be different? Because going from inches to centimeter, what will happen? And you can see they're asking us to do the new correlation coefficient. So let's take a look over here. This is based on our new table now from centimeters. So you can see, again, we selected the entire height column as our explanatory variable, and then the head circumference as our response variable. And you will see that this also, and again, if we expand those numbers out, comes out to be exactly the same, because just changing the unit of measurement from inches to centimeters should not affect your correlation coefficient. And this is also 3 decimal places. Has no effect on the value of R. So it should stay the same. So if your answer does not come out to be the same, that means we messed up on our calculation somewhere. Okay, so just be careful about that. You should expect to see the very same answer come out of here. So questions on this example over here, guys. So this one, as far as the calculations go, is not hard. It's just a lengthy problem, and it takes a little bit of time to, get through the entire steps. But using technology, as you can see, will definitely make your life a lot easier. One thing that I did want to show you, oh, did I not open? I guess I did not open your course shell over here. Oh. Okay, again, under the view section, when you go under week 7, oh, it's not under view. Where did I put it? Oh, it looks like I haven't added those videos. I will go ahead and add the videos, because I have actually created videos on a couple more examples from chapter 4. As you can see, there are other examples that I have in here. So I have created videos for that. I will try and find those and upload them under the view section, so you guys can look at some other examples as you're going through homework. So that way, if you get stuck on anything, you have these videos to look at. So I will go ahead and upload those. So again, guys, just to remind you very quickly, you have chapters 11 and 4 that you're working on this week. Make sure you send me an email to request a password for that. Do it before Thursday. I am not going to be available on Friday and Saturday. Like I said, I'm having a procedure done, so I will not have access to any email, internet, or anything while I'm there. Another thing, you are working on older homework assignments and quizzes this week. If you want to retake any older exam, you need to let me know that also before Thursday, which exam you want to take, and then I'll set it up for you and send you your password. For next week, you will need to request the password for the take-home version of the final exam. For the in-class final, I will give you the password when you come to class. And you'll take the in-class, of course, on Zoom with me. But for the take-home, you will need to request a password for that. So you can do all of that this week if you like, and I will have all of those ready for you, and I'll send it out as the time comes. So if you have any questions, I'll be happy to answer them. And then I will see you guys next week for the final exam. So, good luck, everyone. Be careful, stay safe. And if you have any questions, please stay back and I'll be happy to answer. So take care, guys. Be careful. And I will see you next week. Have a wonderful day, everyone. Be careful.
Thank you.
Thank you. Take care.